In this last video in the playlist, I want to try to accomplish two things. First, I want to make sure that we practice using the formula in question number 3, letter A, to ensure that we have the tools needed to be able to complete these questions. And secondly, I want to do a quick summary of everything that we learned on page 11 so that we can start recording some of this information for the long haul. Obviously, we're learning formulas, which do involve a little bit of remembering. And the good news is, since we're learning from home right now, these formulas don't have to be memorized. You'll have access to your notes and your packets anytime you need to do something like an alternate test or a quick check where you're going to need to be able to use these formulas. So memorizing shouldn't be the goal, but I do hope that you'll start to think about the importance of knowing these formulas and recognizing when to use them so that you don't have to start from scratch every single time. So that when you see a problem, you can kind of quickly recall and say, ah, yeah, that's the geometric one, I know that one. Or, oh, that's the arithmetic one, I know that one. And they look very different, they have very different usages, they have very different applications, so making sure the difference between the formula that we learned today and the formula from the previous lesson, the Gauss formula, is distinct. In any case, let's bite off one thing at a time. We're going to start with number 3, letter A, and make sure we're good there, and then I'll do some last minute recording of formulas to make sure that we have some steps to walk away with. The instructions in question number 3 say to find the sum of the first 8 terms. So I just really quickly want to make sure that I highlight that, because the first 8 terms is actually giving me a very tangible clue about the fact that n, remember how n in our formula is the number of terms in the problem? N must be 8 for all the problems in this section, because there are 8 terms in every single problem that we're going to do. They usually give us only a few terms to kind of kickstart us, but because we're going to have to find the sum of all 8 terms, even the ones they're not giving me explicitly, I want to make sure that I know n is 8. As you probably recall, there are 3 main parameters that you have to make sure you have numbers for. A sub 1, which is the first term, r, which is the multiplier, and n, which we just discussed, is the number of terms. So we know now for sure that n is 8. We can feel confident about that. A sub 1 is usually pretty easy to spot. A sub 1 is the first term in the series, so a sub 1 must be 5, because I can tell the first number they gave me is 5. And then just by quick inspection, 5 times 3 is 15, 15 times 3 is 45, 45 times 3 is 135. I can tell the multiplier is 3. There's my r. So setting up the formula actually does get a little bit easier once you know what you're looking for, because these are all fairly obvious things that should be given to you when you are starting a new problem. You shouldn't have to dig very deep for any of these parameters. Now, of course, you'll need to know your formula, and I'm looking up at the top of the page at number 1, letter C, to confirm that my formula is a sub 1, which is 5, times 1 minus r, which is 3, to the power of n, which is 8, all over 1 minus the same r, so 1 minus 3 again. Now, again, depending on your calculator fluency, you may or may not feel comfortable doing this in one calculation. You may feel like it's better to do a bunch of different calculations and then just kind of stitch them together. You'll have to decide what's best for you and your skill set, your device. I personally don't necessarily mind typing this all in at once. I could do 5 parentheses 1 minus. Now I like to do separate parentheses for anything that has an exponent, just to make sure my calculator processes that, as something similar. So 5 parentheses 1 minus parentheses 3 to the power of 8. That's kind of an unnecessary step, I'll be honest, but it's just a good habit to build. Divided by, and I also like to type the denominator in its own parentheses, 1 minus 3. Some people may argue it's easier to just type -2 in that spot, so you decide for yourself, but I'm getting 16,400, which is actually the correct answer. It is 16,400. If you got that answer a different way, that is completely fine. You will not be asked on any sort of assessment to do the problem with the formula. It'll simply ask you find the sum, and if your method of finding the sum is to find all 8 terms and add them up one at a time, that is completely fine. Whichever way is more efficient for you is the way that you should stick with. So that, in essence, is what we're going to do for all of the problems in question number 3 And up at the top of the following page, question number 4. If you imagine that this task today will end after question number 4, notice I just kind of drew a line across my paper. Question numbers 5 and beyond are a separate task that have a completely different formula, which is why I'm going to ask you to not bother with those in this specific lesson. Instead, just take the time to finish all of page 11 and the top of page 12 only. And then just kind of stop and let those ideas marinate, make sure everything makes sense. I think the last thing that you should do, whether it's now or after you finish these problems, is to start kind of summarizing what we've done with series up to this point on some sort of notes sheet. Now, if you've printed the packet, you may have access to that front page that I always use as the cover sheet for a packet, where you can start to record things like this. But even just a piece of scratch paper that you see yourself hanging on to would be fine as well. Now, the reason why I want to make sure that we have something recorded from here is because we've actually learned 2 formulas, one for the arithmetic series and one for the geometric series, and they're both so different that I feel like it may be worth making an extra little note to ourselves so that we can keep straight which is which and when you use each one. The geometric series is for anything that again is an adding problem that has a geometric pattern, and the formula was the a sub 1 times 1 minus r to the power of n over 1 minus r. Now if you want to take the time on this front page to actually point with arrows and remind yourself that a sub 1 is the first term, that n is the total number of terms in the problem, or total number of terms you're adding, and that r is the multiplier, this would be a good time to kind of spell that out. Now, if you're a color coding kind of person, you might want to color code all of these different parameters, but these are all kind of optional steps that you can decide depending on whether or not you need that level of clarity. These are your notes after all, so make them as clear or as unclear as you feel they need to be. Now, in case you're wondering about arithmetic series, that was from the previous series of lessons, the ones where we talked about Gauss. So just in case you don't want to go back to your old notes or rewatch those videos again, the reminder is that the formula for arithmetic series that I believe we settled on was 1/2 times the first term plus the last term times last minus first divided by the adder plus 1. So if you forgot what all of those parameters are, or if you need a quick refresher, I'll just remind you. A sub 1 was the first term. You'll see that that notation is pretty consistent in both the arithmetic and the geometric formulas. A sub n is the last term. And conveniently, those 2 terms end up appearing twice. A sub 1 and a sub n appear in 2 different spots in the formula. Adder is pretty straightforward. We know what an adder is. And then, of course, there are a few constants, like the 1/2 and the 1, that you don't substitute. Those are just part of the formula. So, long story short, going forward, especially when we start to get into review, you'll have to know by reading a question whether it's arithmetic or geometric and which formula is more relevant to the problem. So that's going to be a bigger challenge in the big picture. For now, though, let's just digest one formula at a time. Between now and the time you start the next lesson, make sure that this idea of the geometric series really has sunken in. Make sure that you know how to identify things like a sub 1, r, and n. Make sure that you have a working calculator or a way of actually doing the computation here. And then make sure that you have a way of verifying your answer, the answer key, or some other way of making sure that the answer makes sense in context. For example, sometimes people make calculator mistakes and they get answers to questions like number 3, letter A, that are negative. They'll get negative 16,400. And they just write it without even thinking about it. Like, well, that's what my calculator gave me, so I'm done. Just think about it. You're adding a positive 5 plus 15 plus 45 plus 135. That's a bunch of positive numbers that you're adding together. Big positives. How in the world would you get a negative answer? It doesn't even make sense. So always ask yourself when you finish a question, did that answer make sense? Because if it doesn't make sense, there's usually something wrong with the formula. Maybe there was something plugged in incorrectly. Or maybe, honest mistake, maybe it's a typo in the calculator. A parentheses was missing or something was in the wrong spot. So take that extra time to make sense of your answers before you assume that you're good with the formula and ready to move on. In any case, the goal today, to reiterate, is to finish through page 4, which is at the top of page 11, or sorry, top of page 12, and to make sure that the geometric series makes sense. In the next lesson, we're going to do a total twist on the geometric series, which is why I'm thinking of it as a separate task. So whether you want to bite off that task immediately or after some digestion time, that's your choice, but hopefully now you have a sense of at least how to get through question number 4.